moves is backwards. What if motion in space doesn't start with gravity or spinning clouds, but with sudden bursts of pressure pushing matter outward?
Really? That's quite a twist. So you're saying gravity isn't the main driver of motion in space?
Exactly. It turns out that motion actually begins with what's called a pressure impulse, a sudden directional burst of force, like an explosion or a rapid release of pressure inside matter.
Oh, that's interesting. So, like when water shoots out of a fountain in any direction depending on the nozzle?
Yes, that's a perfect example. Just like water is pushed out by pressure, stars, planets, and even galaxies get their initial push from these pressure impulses, not from gravity pulling or spinning clouds.
So gravity isn't starting the motion, but what is it doing then?
Gravity acts as a constant inward pull that restrains and curves motion. It can't push matter sideways or start horizontal movement. It's more like a tamer, shaping the paths after motion has already begun.
That really flips the usual story on its head. We always hear that gravity causes planets to orbit because it pulls them in, right?
Right, but the key is that gravity only pulls inward, vertically, or in what's called the normal direction. It can't create or change horizontal motion.
Can you give an example to make that clearer?
Sure. Think about throwing a ball. The horizontal speed you give it stays pretty much constant, ignoring air resistance, while gravity pulls it down vertically. That combination creates the curved path we see.
So the ball's horizontal motion comes from the initial throw, which is like a pressure impulse, and gravity just pulls it down?
Exactly. The same principle applies to planets orbiting stars. Their horizontal momentum comes from an initial pressure impulse, and gravity curves their path inward, creating stable orbits.
That makes sense. But what about momentum? How does that fit in?
Momentum is the real carrier of motion. It's a measurable quantity, mass times velocity, that carries motion forward after the initial impulse.
So it's different from inertia, which is kind of a vague idea about resistance to change.
Yes, inertia is more of a concept without a clear mechanism. Momentum, on the other hand, is directional, quantifiable, and can be transferred or consumed by forces like gravity or friction.
So once a body is pushed by a pressure impulse, it gains momentum that keeps it moving until something slows it down?
Exactly. That's why planets keep orbiting, stars drift through space, and motion persists even in the vacuum of space.
Got it. Now, what about spin? We often hear that gravity causes things to spin, or that planets inherit their spin from a rotating cloud.
Actually, spin comes from torque-like impulses, forces applied off-center that twist a body. Gravity can't create spin because it acts only inward, not sideways.
Interesting. So the moon, for example, doesn't spin on its axis like we usually think?
Right. The moon keeps the same face toward Earth, not because it spins, but because it moves along a curved path shaped by Earth's gravity. It's more like constrained linear motion than actual spin.
That's wild. And what about odd planetary spins, like Venus spinning backward or Uranus tilted on its side?
Those are explained by unique torque impulses during their formation, basically different pushes and twists at the moment they were ejected, not inherited rotation from a spinning cloud.
Speaking of ejection, how did the solar system form then?
Instead of forming from a slowly spinning cloud, the solar system formed from a massive ejection of matter from the early sun. This ejection pushed fragments outward with different speeds and spins.
And then gravity curved those fragments into orbits?
Exactly. Heavier fragments stayed closer, forming rocky planets, while lighter gases traveled farther, forming gas giants. This explains the variety of planetary spins and orbits better than the traditional nebular theory.
That's a neat explanation. Is there a way to predict whether a body orbits, escapes, or falls back?
Yes, there's a simple universal speed rule. You compare the body's speed at a distance from a mass to a circular speed given by the formula. Versus equals the square root of g times m divided by r.
Okay, so g is the gravitational constant, m is the mass of the central body, and r is the distance?
Exactly. If the body's speed equals this circular speed, it orbits in a circle. If it's less, it spirals inward. If more, it escapes or follows an elongated orbit.
So this simple comparison applies from planets around the sun to stars and galaxies?
Yes, it unifies motion across scales, giving us a clear way to understand orbits and escape without complicated assumptions.
That's really powerful. So why does all this matter for how we see the universe?
Because it challenges popular ideas like dark matter and dark energy by explaining galactic rotation and cosmic expansion through real, measurable momentum and gravity. No mysterious forces needed.
It also clarifies the origin of motion, spin, and cosmic structure in a way grounded in observation and classical physics.
Exactly. It helps us see the universe as a mechanical system where motion is initiated by pressure impulses, carried by momentum, and shaped by gravity.
That's a refreshing perspective. It makes cosmic motion feel more tangible and understandable.
Yeah, and it connects the big picture to everyday experiences, like throwing a ball or watching a fountain, making the universe a bit more relatable.
Definitely. So to sum up, motion starts with pressure impulses pushing matter. Gravity pulls inward shaping paths but doesn't start motion. Momentum carries motion forward. Spin comes from torque. And the solar system formed from a massive ejection, all explained by a simple speed rule.
Perfectly said. It's a new way to look at the cosmos that's both elegant and grounded in what we can observe.
I'm going to think about that next time I watch water shoot from a fountain or look up at the stars.
Me too. It's amazing how much the universe's story changes when we rethink the basics.